Number 6, for a time being between 0 and 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals cosine pi over 6t. The particle is at position x equals -2 at time t equals 0. Part A, for the times between 0 and 12, when is the particle moving to the left? Well, if we're talking about how the particle is moving, we definitely want to find the velocity. We'd want to find where the velocity is negative, so the first thing that I'm going to do is do a velocity chart. So I'm going to need to set my velocity equal to 0. So I'm going to be setting cosine of pi over 6t equal to 0. And when I do that, I guess a couple different ways I'm going to think about this. I'll try to think about it the way that you might. I want to figure out where would the cosine equal 0, and I know the cosine would equal 0 at pi over 2, so I am going to pi over 2, and it also would be at 3/2 pi. So I need to think, if I wanted this to say pi over 2, what would I have to put in for the t? And I would think to myself, if I put 3 in for that t, pi over 6 times 3 would be pi over 2, and the cosine of pi over 2 equals 0. And then the other one, how could I get this to say 3/2 pi? Well, if I put t equals 9 in there, pi over 6 times 9 is equal to 3/2. Cosine of 3/2 pi is also 0. So, those are my t values, but I'm not done yet. We want to find out where the particle's moving to the left, so I'm going to make a velocity chart. I'm going to put 3 and 9 on it. Before 3, I'm going to pick 0. So if I plug 0 into the velocity formula, I'll get the cosine of 0, and the cosine of 0 is equal to 1, so that's going to be a positive value. Somewhere between 3 and 9, I'm going to pick pi. And if I pick pi, no, I don't want to pick pi because I need a number. Never mind. How about I pick 6? That will be good. If I pick 6, pi over 6 times 6 is 1. So I'll get the cosine of pi. The cosine of pi is -1. So that will be negative. And then if I pick a number bigger than 9, so let's say I pick 12. So if I pick 12, pi over 6 times 12 is 2 pi, so the cosine of 2 pi is 1, so that is also a positive value. So it is asking me when the particle moves to the left. I'm going to say the particle moves to the left on the interval from 3 to 9, and that is because velocity is negative, and we definitely needed to know our unit circle on this one, I suppose. And this one was worth 2 points. If you even considered this right here, if you set the velocity equal to 0, you're going to get a point. And then if you actually found the interval from 3 to 9, that was also worth 1 point. Okay, part B. Write, but do not evaluate, an integral expression that gives the total distance traveled by the particle from time t equals 0 to time t equals 6. Well, if you have your formulas memorized, this should be an easy problem. Total distance traveled, if you remember, is the integral from a to b of the absolute value of velocity. So this one should be a pretty easy one. All we need to do, we're going from 0 to 6. It's the absolute value of velocity. So here's my velocity formula. And voila, that is done. That was worth 1 point. Hopefully you got that one. Part C, find the acceleration of the particle at time t. That's number 1. And then, is the speed of the particle increasing, decreasing, or neither at time t equals 4? Explain your reasoning. Okay, so we've got 2 things going on here. First of all, find the acceleration. Well, we know that acceleration is the derivative of velocity, so acceleration is the derivative of velocity. And I am actually on this one, since velocity is equal to cosine pi over 6t, I'm going to be doing a u substitution, so I'm going to let this be cosine u. So when I'm finding my acceleration, the derivative of cosine is negative sine u du, and so now I just need to find what that is. We're going to have negative sine of pi over 6t times du. The derivative of pi over 6t is pi over 6. So that's my acceleration, but it said to find, okay, find the acceleration of the particle at time t, which I did. So that is my acceleration formula. That was worth 1 point. Great. And then it says, is the speed of the particle increasing, decreasing, or neither? Well, I know to find if the speed is increasing, decreasing, or neither, I need to compare the signs on the velocity and the acceleration. So first of all, I need to find the velocity at 4, and then I need to find the acceleration at 4, and then we need to know about their sign. So the velocity at 4, I'm just going to plug 4 into the velocity formula, and that will give me the cosine of 2/3 pi. Let's see if I'm having my hand out. 2/3 pi, it's my middle finger, so the cosine, oh, it's not my middle finger, it's my index finger. The cosine is above it, so it's going to be 1/2. And on this one, on the unit circle, cosine 2/3 pi is up here. The x value over there is negative, so this is going to be negative 1/2. And the acceleration is going to be negative sine of pi over 6, whoops, times 4 times pi over 6. And that will equal, let's see, that will be negative sine of 2/3 pi times pi over 6. And the sine of 2/3 pi is going to be the square root of 3 over 2. And up here the sign is positive, so this is actually going to be negative square root of 3 over 2 times pi over 6, which gives me negative square root of 3 pi over 12. These both have negative signs, so if the velocity and acceleration are both negative, the speed is increasing. So I'm going to say the speed is increasing. That's great. Because v of 4 and a of 4 are both negative, and if they were both positive, we'd have the same results. And that was worth 2 points. So if we figured out it's increasing, we'd get a point, and if we said why, we would also get a point. All right, part D, find the position of the particle at time t equals 4. Well, I know if I'm at velocity and I'd like to go to position, I know I need to take the integral, so to get the position, we'll call that x. It's going to be the integral of cosine pi over 6t. And since I have parentheses, I'm going to do a u substitution. So u is going to equal pi over 6t, which means du is equal to pi over 6. And I'm missing the pi over 6, so I'm going to put pi over 6 on the inside, 6 over pi on the outside. So I'm going to end up getting 6 over pi, the integral of cosine u. And I know the integral of cosine u is just sine, so we'll get 6 over pi sine of u plus c. Don't forget your plus c. They did give us some information to help us find the c, so let's see if we can plug that in. X is negative 2 when the time is 0. Sine, and if I put 0 in for my t, I'll just get the sine of 0. The sine of 0 is 0, so we know that c is negative 2, so my formula is x of t equals 6 over pi sine of pi over 6t minus 2. So I found the position, but I want to find it at t equals 4. So now we're going to plug 4 in for my time. So I'm going to have 6 over pi sine of 2/3 pi minus 2. We found out in a previous problem that the sine of 2/3 pi was equal to negative square root 3. Actually, it was equal to positive square root 3 over 2. So times 6 over pi minus 2. And I guess we could simplify that if we wanted to. I think I will. If you left it like that, that would be totally fine. They won't mark you off for it. I get the 3 square root of 3 over pi, because the 2 and the 6 cancel, and then minus 2. So that would be my position at time t equals 4. That was worth 3 points. If you correctly found this antiderivative right here, that was worth 1 point. If you used the initial conditions, so if you found c, you'd get a point. And then if you got the correct answer, that would be worth 1 more point.